I've got a piece of equipment here out of my storage shed. I thought you might be interested in seeing how it works, if it works. Very heavy. The first thing I notice is the end here. It had been supplied with the third grounding pin. You can see that somebody cut it off with a pair of diagonals. There were a lot of shops and a lot of portable generator sets that only had 2-prong outlets. So rather than replace their outlets or get an adapter, they elected just to cut the grounding pin off the cord. Very heavy. It's supposed to be portable, but back in the day where men were men. What we've got is a Jerrold, nameplate up here, sweep frequency generator. So it's a signal generator, an RF signal generator. And there are coarse frequency selections made with this switch. The lowest is 12 to 45 megahertz, and the highest is 45 to 225 megahertz. Right now I've got 42 to 175 megahertz selected. So the output frequency will be centered, well, the output frequency will be somewhere between these frequencies, selected with this knob here. So this is an arbitrary setting, 1 through 10, which will output a frequency at this B and C connector, somewhere between 42 and 175. We have a level system consisting of 2 attenuators and an automatic level control. And we have a knob called sweep width. Now with this knob set to minimum, this device should output a single frequency. This frequency is determined by the combination of these 2 knobs. As we increase the setting on this dial, the frequency will begin to sweep back and forth at about 60 hertz, well really at power line frequency, which in the United States is 60 hertz. The width can be varied with this, wide or narrow. I've gotten information from a website that is dedicated to the history of Jerrold Corporation, which was a Pennsylvania CATV, community antenna or cable antenna manufacturer. Of course, we're talking analog television. Probably in the 50s or 60s. Anyway, this is the data. Well, I guess this is the way Jerrold advertised it. It's a portable device for laboratory production or field use. Some data. There were 2 models made, a 601 and a 602. This is a 601. The difference is the start frequency and the maximum frequency. The 602 starts at a lower frequency but doesn't go so high. Specifications, well, function of the front panel controls and specifications. 7 vacuum tubes. It develops a plus and minus 225 volt supply and a 200 volt AC supply. It also develops a 3.6 and a 5 volt supply for the tube filaments. Although I don't see a 5 volt filament vacuum tube. They appear to be all 6 volt, including the 12 AT7s, which have 12 volt filaments, but they're center tapped. We will look inside and see if there's a vacuum tube rectifier, which are normally 5 volts AC. I wasn't able to get a complete schematic. This was available in 50 ohm or 75 ohm, 72 ohm, 75 ohms. This one must be a 50 ohm device, has B and C connectors. If it had F connectors, it would be 75 ohms. So I just hooked it to my spectrum analyzer and I'll power it on. I better plug it in first. Now, this should be the power indicator light. This little Jerrold logo lights up. If it did, I can't see it. So looking at the spectrum analyzer, we see a frequency here, but it appears to be pulsing on and off. That's because the output of the signal generator is not on all the times. It comes on briefly for every 60th of a second, a little pulse. But we can, if I do this correctly, this device can memorize the maxima on any frequency. So it's holding the maximum. And we'll see what that is. So that's around 143 megahertz. And if we look at the scale 42 to 175, that's reasonable. I'll turn off the peak hold. And I'll increase the sweep frequency, or the sweep deviation. And you see what we get are random movements of the center frequency. We'll go back to this peak hold option. And what happens is it begins filling in using the peaks. Now here's a second harmonic apparently. Alright, so it's outputting a frequency. We'll move marker 1 around. And we'll put it up there. And we'll create marker 2. And we'll put marker 2 down there. So you see right now it's sweeping between 1 and 2. I'll go back to this sweep width control and turn it up to maximum. And you can see it fills in, it's sweeping now well above 1 and well below 2. And slowly it'll fill in. Now, because this has a memory to it, if I turn the sweep width back down, the trace doesn't change. But if I turn off a clear, there we go. I'll turn up to maximum the sweep. You see we have random variations. If I put on the max hold, it begins to fill in nicely. So let's go up to, we'll clear it. I'll just increment up using the range switch, 1. Okay. And turn the range, turn the sweep back down, turn the memory on, set the marker at peak, and we'll see that's the frequency of 182 megahertz. It jittered around a little bit and it memorized that. But move marker 2 to the peak. Now we'll increase the sweep. And it doesn't seem like it's centered around marker 2. It seems biased towards going down. And the second harmonic appeared. Now, Jerrold advertises the flatness as being, let me see what it said. A maximum difference of 1 decibel. So we'll set marker 2. Up here somewhere. And we'll set marker 1. Up here somewhere. And you see the difference is less than 0.5 decibel. Pretty good for a 50-year-old device. I'll turn the memory off again to clear it. And I'll put it back on hold. And there it is. I'll change sweep width on this device here. I didn't change the sweep generator output, I just expanded the window. So what we've got is this device outputting, let's see, I have 10 dB of attenuation inserted. So it's outputting around 5 decibels. Well, really closer to 6. Marker 1. And marker 2. Yes, there they are. Marker 1 is 5.96, call that 6. And marker 2 is 5.52, call that 5.5. The flatness is within 0.5 decibel. We'll tear this thing apart and see what makes it tick.